Okay, you requested me to do some video. Let me confirm my mic is working well. Fine. You requested me to do a video of the input circuit, and you also wanted to know how the diode works, how a diode works and the input circuit. I'm having one motherboard here, and I think this one is a little bit different. Let me get another board. Let me get another motherboard that we can use. I'll get the exact same motherboard we used yesterday. It's a motherboard for Folio 9480 or 9470, probably one of those. Yeah, so this motherboard has a power jack that is removable from the cable with a cable. Okay, so it is detached with there's an extending cable that attaches to the motherboard, and the other one attaches to the power jack. So you'll not find the direct power jack on this exact motherboard, but you can find where the connection of the power jack is, and it's on this side here. Should be on this side. You can see this one is for fan and one is for power jack. So this one is for the power jack, so it enters like that. And from here I want us to trace the track. I want us to look at the MOSFETs that are around in the input circuit. And there was a diode yesterday, right, that we were supposed to be checking, and we'll also check that diode. So I'm going to do an extensive video regarding the same. And now we are going to switch my microscope. Switch to my microscope. Okay, good, fine. At this far end we have two connectors, and they are the same connectors I showed you. So one connector is for the fan, and one connector should be for the power jack. Let me reduce my video. So this first connector should be for the fan, this one should be for the power jack. Right together. How did I know? It's easy. Usually tracks carrying voltage are usually very big. You see, a track like this one is a track carrying voltage. This one probably is the ground. So we have no such track here, and I would not presume this one to be the one carrying the power, right? This one, I would not presume it to be the one carrying the power. So we're having three connections here. 3 pins are connected together, 1, 2, 3. Then 2 pins are connected together, 1, 2. Then 1 pin is connected together on its own, probably the enable pin I was talking about. Now we were talking about what an enable pin is, and enable pin is just a pin that detects whether the charger plugged in is a genuine charger or not. Yeah, and in most cases, I told you it is available in mostly very current generation motherboards. This pin, the pin that is on its own here, could as well be a protection line, right? That is directly connected to the diode that does the protection for it. In this case, it could be the enable pin probably that does the protection, and is directly connected to this diode here, right? This is a diode, the D615. That is how you know this is a diode. Then we also have a fuse here, which is part of the input circuit. Then we also have the first MOSFET, which is part of the input circuit. We have the second MOSFET, which is part of the input circuit. We have the current sense resistor, which is part of the input circuit. And we also have two other MOSFETs here, which we might not know at this point. Probably the charging high side and low side charging MOSFETs. Probably here they are. And this one, again, probably looks like the comeback MOSFET or something. Eh? We also have a current sense resistor, probably part of the battery charging. I see we have a solder ball here. Remove it. Okay, fine. So we have seen a series of items. Eh? We have seen a series of items, and let me see if I can draw them. Notebook. We have seen a series of items, and we can try draw them. Okay, fine. So we will start our drawing. Let's put it as full screen. So what we have seen there is let me get this pen. Let me put it full screen, thank you. And we get a better pen, right? Good, that looks like a better pen. Let me get color white. Let me get, where do we get the color from? And I think, okay, fine, we can use that. So we usually have a power jack here. Then from the power jack, we slide into a fuse. This is a fuse. Then from there, or a low carbon resistor, right? Then from the fuse, this power gets in to the first MOSFET. This is the first MOSFET, right? Then it gets in to the second MOSFET. We have second MOSFET, right? Then these are the gates. These are the gates of the MOSFET. Now, on this first gate, on the gates, we said if they are n-channel MOSFETs, we should be getting between 26 and 25 volts on the gate, right? Same to this one, n-channel 26 to 25 volts on the gate. And if it is p-channel MOSFET, we should be getting something below the entrance voltage. So probably we should be getting 13 volts or 17 volts or 18 volts. Same to this one, 13 or 17 or 18, depending on the type of MOSFET. And these two lines are directly connected to what we call the AC drive, right? AC drive, which goes into the BQ chip, right? Then from here, we will be having a low carbon resistor, and here is where we get our 19 volts. So we had some other pins on the BQ chip, so maybe they will not be important for now, right? Then we have the face. We have the face, which should be 6 volts, right? And we checked 6 volts. This is on BQ24780S. A phase switch probably should be around 6 volts. Then we also have other 2 pins which do connection to the SIO to connection. Then we have the proc hot pin which probably goes to the CPU, right? And it controls the temperature of the CPU and something of sort. So this particular BQ chip, it has those functions. It does protection of the motherboard, protection of the input circuit by controlling the gates of these 2 MOSFETs, and what other function? Manages charging, for the battery. So this is the typical connection. This is the most simplest typical connection that you will get in such place. Then so let's just use this. Let's just use it, and we will go to the power jack. Right, here's the power jack. It goes probably through this diode. Then we have the fuse, which we are talking about. Check our diagram. You can see the fuse. Here is the fuse. Then here is the first MOSFET. Then here is the second MOSFET. Then here we have the low carbon resistor. So at this point we have 19 volts. Now we are having a diode here which you are talking about, right? And let's open my power supply. I want to show you how to check for a diode, right? You'll take your probes. We're having 3 pins. We have 1, 2 and 3, right? So this pin is the ground. Let's confirm. You can hear the beep. This is the ground. I've made reference to this and the ground. This one is the positive. There is no beep. And this one probably is that enable line, right? Good. Now we will not deal with this. We need to deal with these 2. We need to deal with those 2. We need to deal with those 2. And thank you. So what we do, check the continuity between here and here, and there is nothing, right? Now exchange the probes and check between here and here, and no, it's supposed to be in diode mode. Let's confirm diode mode. Good, diode mode. So at this point we're getting a reading of 2.4. Check, we're getting a reading of 2.432, right? Then exchanging the probes, this point and this point, we are not getting any reading. Check OL, meaning there is an open circuit. So that is how this diode should be functioning. So at this point you know that this diode is working. Any other thing like the voltages and all that, you can check in the schematics if they're right or not, right? And that is the working principle of this one, so that power does not cross path. And the diode works like a net where it will filter off, and it just disabling reverse current, so that current does not come back, and that could cause problems. Then coming to the fuse, you check through continuity. The diode mode could also work. You will get a very infinite reading like that, 0.003, and that could be the resistance of my, same to my probe, right? You can check. Come to resistance mode, or we come to continuity mode and check. That is how you check a fuse. A fuse is like a wire, just to allow positive current, right? We come to our first MOSFET, we check the gate and the source, and there's open circuit, right? Then we check the gate and the source. That's okay. We come here, we check the gate and the source. There's no reading, right? That's okay. We check the drain and the source, and that's also okay. So that is how you check a MOSFET. Check for a short between the gate and the source. Check for a short between the drain and the gate. We come to this low carbon resistor. This is a resistor with 0.010 resistance. So that is the reading you should be able to get, which is 0.3, 0.2. Still okay. So that resistance is functioning well. At this moment in time, you are free to do what? To insert your charger to check the voltages. Then we're talking about this gate. This gate goes directly into the BQ chip. This gate goes directly into the BQ chip, and we can look for it. So here we have our BQ. Let's confirm. TPS. No, this is not our BQ. That is not our BQ chip. So if it is probably in a place where we can no, not in that place. Let's check our BQ chip, and BQ736, right? Here's the BQ we are using, the BQ736. Let's make it more visible. Let's make it more visible. Is it? No, it's not visible still, right? Okay. You can see that? I want you to check BQ736. You've seen that, right? Now, after seeing that, then I don't know how you're going to confirm, because it's on this other side of the motherboard, right? I don't know how you're going to confirm, but either way, let's change it to beeping mode. No, that's okay, it's in the beeping mode. So the gate is very small. I don't know how we're going to, we're really going to struggle to check it. We're really going to struggle to check it. Let me switch to my desk. We're really going to struggle to check it, simply because the Nini is on the other side, the BK chip. But let us try. Let's try and see if you hear a beep, and we are good to go. Check. You hear the beep? You hear the beep? I'm sorry you can't see on the microscope, right? It is on the gate. The gate of the MOSFET here. And the gates of the MOSFET, right? And we check again. You hear the beep? So that is exactly where that connection is, and it should be, I think, on this pin, right? Okay, and that is where it is. So it is directly connected into our BQ chip. This is not BQ2470S, but regardless, the connection must still be there. The connection must still be there. So if the gate has a problem, you also come and check voltages. Number one, you must check whether this capacitor okay. This one is okay. This one is okay. This capacitor, let's see. You remember the capacitor we were talking about? The capacitor that connects the capacitor that connects the current sense resistor, right? So here we have the capacitor. Remember, these are different BQ chip, so it also has the same issue, not issue, but same capacitor that connects the two lines. So from here, you know that is where the line is supposed to be. So however much it's beeping, it's not shorted. Then we also check other capacitors for a short. Just check randomly, right? Just check randomly. Check randomly. That's okay. So everything looks okay and there's no shortage. Then you should check for 6 volts. You should check for 19 volts that powers the chip. You should check for the 26 volts that comes out and controls the gates. Those are very important places to check, right? And then I was to do also a video. I think we are done with that input circuit, so let's just get into the next class. Generally, what do we check when a motherboard is faulty? Now assume that we've checked all the other things. Assume that we've checked all the other things, including the input circuit and all those things. Or assume that we want to start to check this motherboard to know where our problem is. Of course, I'll check the input circuit first, but I'll go for the input circuit after I've checked the whole motherboard, just perusing through. Now, the first and very important thing to usually check is check whether we have the main power rail, which is usually 19. I don't have a power jack for this motherboard. This is a type C board. Let me get the other. Let me get the one that we've been using before. But let's use this one. This one has a dead CPU. Let's plug it in. And I wanted to check the power supply, right? There's something plugged in to our power supply, and I want to remove it first. We'll check the others later. Check the behavior of the power supply first. So usually before you plug the motherboard in, just to protect the motherboard, right? What you should do first is check if there is a short. So change your multimeter to continuity mode. Then come and check for main power rail capacitors. Now main power rail capacitor, you check for a combination of maybe a coil and a MOSFET or 2 MOSFETs. Then there you know that the main power rail is there. This is what I'm talking about. This is what I'm talking about. No, this is what I'm talking about. Phase. Look for a coil and a MOSFET or 2 MOSFETs. Now we have an architecture here. You've seen that? We're having a coil, we're having 2 MOSFETs, and we're having a capacitor. Definitely that capacitor is the main power. So check for a short there. Check for a short there, here, and the main power rail is okay. Let's check another. We also have a power supply here, a power supply here. We have a capacitor here. These are these are coil, and we have 2 MOSFETs. This one definitely is the main power rail. Check for a short. Now you've seen what I was trying to say. The capacitor was charged, and that is why you've had the beep. So it might confuse you to be a shorted capacitor, but it's not. But right now, if we check, it's been discharged. So the capacitor is okay, right? Then at that point in time, you're quite sure that your main power rail is not shorted, and therefore you are very safe to plug in your. Now let's plug in. I don't want you to lose focus on that power supply, because I want us to check the main power rail in that power supply. Plug in. Check my power supply is taking 0.028 and the motherboard is not coming on. And if you check with the thermal camera, the CPU will be gone. But let's check for 19 in that particular area. This one has, let's see, let's switch to that one. This one has 0.8 and this one has okay, fine. Let's check in this cap. This one has 0.8 and this one has 0.8. So we are getting 0.8 in the main power rail on this motherboard. Is it okay or not? It's not, right? And I guess I had not checked the input power supply, right? For a reason. You have to scan through the board first, then after that, then you'll be able to check and see exactly what you need. The main power rail is having 0.8 and that is not correct. So from there I go into the input section. So this motherboard also has an issue with the input section. We will go step by step, right? Step by step. This is an AMD CPU or AMD. Let's go to the input, right? We're having the power jack which is plugged in. Check my multimeter. Check my multimeter, right? At this point, this is the ground. You remember the diode we were talking about? So we have the ground. Then we have this enable, which is having 0.6. And we're having here, which is supposed to be having 19 volts. Let's check. It's having 6 volts. Okay. Okay, sorry. You can see my power supply has 6 volts. Can you see that? It's supposed to be having 19, not 6 volts. So let's switch it off. Sorry for that. I was using it to charge. Okay, that's okay now. 19 is okay. So let's check the main power rail. Main power rail again. Here you have 1.2. Here you're having 0.0, and here you're having 1.2 on the main power rail. Just to confirm again, here 1.2, this other side is the ground, and here we're having 1.2. So either way we still have a problem in the input section. So let us just go back, and this motherboard seems to have been worked on before, right? So we were checking here and we should have 19, right? Can see that we're having 19 volts, right? Check my multimeter. We're having 19 volts. Good. Then from that point it goes to this low carbon resistor, which acts as a fuse again. We're still having 19. We're still having 19 at this point, right? Then we come into this first MOSFET, connected to this first MOSFET, and we have the second MOSFET. So at this point, come to the first MOSFET at the gate, we're having 19. That is very obvious. Then at the output of the second MOSFET, we're having 19. So we are still okay. We're still good, right? Good. Now, then from there, we're having the main power rail, which is 19. And we are still okay. up to that point. Now this is a motherboard for I think it's 30G6, and for these architecture motherboards, there is usually a power supply, which is again controlled by the BQ chip or intercell chip that does all those shenanigans. It creates the main power rail, which should power the components in the motherboard. In this motherboard is not powered by 19 volts. This motherboard should be having 12 volts, 13 volts thereabout. That means the battery voltage. So if you checked where we were getting the 1.2, you should be able to see 13 volts, or you should be able to see 14 volts, or you should be able to see the battery power voltage. Now how do you see, or how do you check that a motherboard has that power supply? Now near the input section, we are having a large coil. Then that coil has 4 MOSFETs, 2 high side MOSFET and 2 low side MOSFET. We're having 1, 2, 3, 4, and we're having a coil here. So at the output, the input is here. At the output of this coil, we should be having that 12 volts. This is the output coil, output MOSFET connected to this capacitor, and at this point or pad is where we're having the main power rail, which is 12 or 14 volts or 13, or the battery voltage in that case. So we should be having that voltage here. Let's check it. Remember our charger is plugged in. Now let's check at this point, and we're having the 1.2. You remember the 1.2 we saw on the main power rail? So here is where it's getting generated. Now let's follow it step by step. From this main power supply 19, it goes into this MOSFET, and on this MOSFET we are getting output of the first MOSFET in that case the main power rail we are having 1.2, and that is where the problem is. So anywhere from here, all these MOSFETs should be having that amount of voltage, right? We can check anywhere. We can check anywhere here. We can check here. It's having 1.2. All those MOSFETs. Now let's go to the gate of that MOSFET. Check. The gate is having 1.2 volts. The gate of this MOSFET is having 1.2 volts. Now let's check on the internet what type of MOSFET this is. The 6380. We'll check 6380. 6380 MOSFET, right? Let's see if we have it. Okay, fine. It's taking time to load. I'll not be able to edit it. Just how to release it the way it is. It's an N-channel MOSFET. You can check, or okay, fine. Let me share my screen so that we check it together. So it's an N-channel MOSFET. The AON6380 MOSFET specs N-channel 30V 24A. So it carries 30 voltage, 30 volts and 24 amperes, right? We can check the data sheet. But the data sheet seems not to be there. We have open as PDF. Now this is exactly what we are talking about. From this moment in time, you know where the problem is, because in the gate we are having 1.2 volts, which is not supposed to be there. So this is a problem. This is a typical example of a problem you are doing diagnosis for, right? We have to cancel. So you can see 30V N-channel MOSFET, alpha MOSFET, right? And this is how it looks like. It has the 3 source, the gate, and the 4 drain. So this is how it looks like, right? So at the gate supposed to be having higher voltage. Definitely, any N-channel MOSFET is supposed to be having higher gate voltage. So if the voltage is higher at the gate, it connects the drain and the source, and power passes through from the gate. Drain. Look at here. The gate source voltage should be 20 plus. See that? In this case, should be 20 plus. In this case, it should be 20 plus. We're having 122 volts. Then you know where our problem is. You know where our problem is. You definitely know where our problem is. All those MOSFETs. Now, we are going to look for the PWM chip that controls this MOSFET, right? And let's look for it. And it's usually just beside the coil. This is it, right? That area has been worked on. That is why it looks like that. I bought this motherboard for spares. So let me clean it so that it looks a little bit presentable, right? Let me clean it. Let me clean it. Let me clean it to look somehow presentable, right? Good. I think it looks. The oil is gone. Let me clean my work area and a little bit more cleaning. Good. I think I've done good cleaning for it. And let's go back to that chip. You can see how clean it is now. Now let's identify what type of chip, and it is the Interseal 9538H. The Interseal 9538H. That is the Interseal 9538H. The Interseal 9538H. Let's check for a short around it. Let's check for a short around it. Good. Thank you. Let's check for a short around it. Here. No short. I think my multimeter is misbehaving. My multimeter is misbehaving. Can see? It's not beeping. It's supposed to be beeping, right? And then my probes or batteries. Thank you. Let's check here. That's okay. That's okay. That's okay. That's okay. That's okay. That's okay. But there we have something that looks like a short, right? But we have to confirm if this one is the capacitor we are talking about, right? That's okay. That's okay. So there is no short. We have to confirm first. We have to confirm first. So this probably is that capacitor we are talking about. So what happens in this case? I would gladly be able to inject some voltage here at the gate to check where exactly the problem is. Or The simple way, 9538H. We look for this the data sheet of this chip. Let's look for the data sheet of this chip. 9538H. 9538H. Interseal. 9538H. Data sheet. Okay, 9533H. 9538H. Let me share my screen. Let me share my screen. I have the data sheet here. And we only have equivalent data sheets. We have no exact data sheet. I think the data sheet is not around. Let's look for an equivalent of that data sheet. ISL 9538H. This is the value. So we have no this data sheet, right? But either way, you know that there is a problem somewhere. Now let's check for the voltages around. There are voltages that we should be looking at, right? Voltage. Let me switch back to my scope. Good. Let's check for some voltages around it. And this one is 1.2. This part of the output. This one 1.0. Ground is shorted. There's a short to ground with something. Yeah? Okay, fine. Thank you. I've confirmed. So here you're having nothing, probably ground. Here you're having 1.4. Here you're having so these are current generation laptop, right? 0.5 volts. And here you're having nothing. Here you're having nothing. And here you're having 19. So the 19 that powers the chip is through this resistor here. The resistor is having 19, so this chip is actually powered, but we can't see all the other voltages, right? That probably these are the two voltages that go to the BQ, to this MOSFET. So it could be easier. We could try doing an injection to see if maybe there's a short in that line. And that one you can do by connecting our power supply, and we'll just do 1 volt, 1 amperes, and at the gate of that MOSFET. Let me get my and that is connected well. Then we will come here at the gate, and it's taking nothing, totally nothing. Here is totally taking nothing. Here is taking nothing. Let's check a short between the gate and the source, right? Let's check, and it is okay. There's no short. Okay, and let me shift to continuity mode, and here, so you see where the problem is. And if we could have checked this one probably earlier, we could have seen where the problem is. So there is a short between the gate and the source. having 0.7. Now, that is exactly what I was trying to explain, that at this moment in time, we have two culprits. It's either it is the MOSFET, or we're having a problem with the interface chip. So what do we do? I don't know why we did an injection and there is nothing that is taking the current anyway, because if there is a short, something is supposed to be taking that voltage. But either way, let's check these other MOSFETs. Wait, must be sure this is the gate and the source. Source, gate, drain, right? Drain. I can see the gate here. Can you? Can you see the gate? Okay, the gate is quite away. This one is the gate, right? No, this is the one, right? This one. Yeah. So let's check, and that's okay. Drain and source. Gate and source. You can see that's okay. Gate and source, that's okay. Then gate and source here, and there is a problem. There's a short on that MOSFET. Now we will do a simple thing of removing the MOSFET and wait and see if we still have a short. So let's remove the MOSFET. Let us remove the MOSFET. Let me get my hot here to 380 degrees. That's okay. Then look for some flux. You have to do some neat job. Don't do it the other way, right? Get some flux around it. So number one, you must protect these plastics. There's a plastic here, which probably belongs to the speaker. We have another plastic here. You protect them using this thermal tape. Okay, wait. I was showing the screen. I'm sorry. Okay, let me replace. Okay, fine. Here's the thermal tape. Here's how the thermal tape looks like. Just coat it and the area will not be burnt, right? But again, let me show you. I think I was not recording with my scope. Okay, sorry for that. So this is the plastic I'm talking about, and these are the two MOSFETs. We have to recheck, right? The gate and the source. So here and here, and that's actually okay. Wrong, shorted. So let's take our tape and we use it to coat this plastic like this. So we don't burn it, eh? Yeah, you can see it's been worked on, because if you burn those, if you burn them out, protect the area first. And you also have here protection here. Protect the area so that you don't burn them. So I'm also in this place. I'm also teaching you micro soldering. Yeah? Should know how micro soldering is done. Protect this area like that. Then you go. Good. You can see the plastic is well protected. Sorry. The plastic is well protected. Then so you will come with your flux. With your hot air. My hot air is at 380 degrees. Good. Then we remove the we remove the MOSFET first. So let's remove the MOSFET. To 80 degrees. So we have to be patient a bit because it takes time for the solders to melt. The type of solders they are using are called industrial solders, and they are quite hard to melt. So you must be very patient. You must be very, very patient. You must be very, very patient because using high temperature is again very bad. You might end up burning things on the motherboard. And our MOSFET is out. So our MOSFET is out, and let's clean the area a bit, and let's do some cooling. I usually cool it using this liquid. It's a normal home dry cleaner liquid, mostly used in electronics. Let's give it time to cool. Cooling down. Now we are doing what is called elimination method. We are stuck between two, having the MOSFET or the gate of the ICs, or the MOSFET is shorted to the source. So what we do next is we take our multimeter. Oh, voila. This one, sawa. Sasa nakutumia, sawa. Walai. Tangojea machine bado haijaenda, but mwenyewe anaikujia. Yeah, that is what I want. Siwezi kukudisappoint. Tata jina gani? Irene, Irene Wanguria. Sorry for that. We want to take our multimeter in continuity mode. Then we check the gates and the source, and there is still a short, right? So our MOSFET is actually okay, and we can test our MOSFET and see. Here is our MOSFET. This here is okay, and the first pin here, first three pins are the source. So source is 1, 2, 3, 1, 2, 3, and here we're having the. So here we're having. My MOSFET is gone. Okay, fine. This is how you test the gate and the source. So use these two last pins, and there is no beep. See that? There is no beep. There is no beep. So this MOSFET is okay. There is still beep here. There is still beep here. And now we have actually concluded what our problem is. There is a short between the internal regulators of the of the intercell chip. And what we have to do to restore that main power release is actually have to replace that intercell chip. So you have to look for that intercell chip. So our MOSFET is okay, and we have to get it back. Our MOSFET is okay, and we have to get it back. Let's get back our MOSFET. Let's get back our MOSFET. And get back our MOSFET. Let's add some little amount of flux. Thank you. And the MOSFET is empty. Well soldered. The MOSFET is well soldered. And our MOSFET is well soldered and very intact. And we have to now cool. Let's cool the area again. Okay, that's okay. So we have to look for this intercell chip to replace it, to see the behavior. Once again, how it's going to behave. You must do clean job. Must do a very clean job. Let's do a very clean job, and we are going to wash out all those plugs. Okay. Okay, fine. Let's remove this intercell chip. Checking the first pin first. Okay. And we come with our hot air at 380. And our first pin. Where is our first pin? I think it should be here, right? Let's remove this intercell chip. Let's remove this intercell chip. And our intercell chip is out. It's out, right? So here is our chip. And that area looks good. It actually looks okay. And let's cool the area. So let's inspect our intercell chip for any damages. And the chip actually looks okay. Let me check if I'm having this chip around. Let me check if I'm having this chip around here. Check if I'm having this chip. And my box is not having this chip. That's a MOSFET. This one is not. And we have the PD controller here. Having one PD controller here, and we're having a power stage here. We're having, so this is a power stage, and we don't have that chip, but we should not miss. That chip must be there. Okay, let me look for that chip. Which chip is this? 95859A. Right? And we're having one here, which is Intersil. This is a PQ24s. This is a PQ chip. And I think should be having that chip. I think so. Let me get another donor board. And having that Intersil chip here, right? Okay, this is the same architecture. Oh, this is 9241H. So they're different. They're actually different. I thought I was having that chip. So this is actually a different chip. 94. I don't know if you can see it. It's 94 watts. This is 9241H. You can see that? 9241H. But the chip we are looking for is we removed it, 9538H. So okay, fine. This motherboard has same architecture. I want us to do the testing here. This motherboard with the 91 something H, it is having the same architecture. We'll do away with this first motherboard because we don't have a chip, right? But if you replace the chip, we should be able to get that 19 volts. You should be able to get that 19 volts. Once you replace the chip, you should be able to get that 19 volt. Okay, fine. Let's check something. Let's plug in this one. This one is having same architecture. You can remember these two MOSFETs and these two MOSFETs, current and resistor. The two input MOSFETs here, this one and this one are the two input MOSFETs. And you have the current sense resistor 0.1, the protection diode here, and that's it. So let's plug it in and check our multimeter. It's not taking any current. It's not taking any current, which is okay. First, let's change our multimeter to voltage. Then we check here. We're going to check the output here, and we're having nothing. You see that is actually strange. That is why I was telling you that most of the problem where you'll probably get a lot of problems with is the input circuit, right? Because these intercell charging ICs really die very fast. That's so strange that I didn't know this motherboard also has the exact same issue. We're getting 0.02. Here we are having wait, we're having nothing. And here 0.9. Why? Okay, my power supply again. Should be having 19 volts there. Sorry, I'm sorry. I'm sorry. I'm sorry. I'm sorry. So it's taking 0.02 amperes. So it's taking some current. So we should be having the main power. Is that okay? That's true. We should be having the battery voltage here, which is 12 volts. And that is the exact voltage we're supposed to be getting on the other side of the motherboard. On that exact motherboard we were talking about. So we should be having 12 volts. That is by replacing that IC, we should be getting this type of voltage, the 12 volts. So the battery voltage in this case is 12 volts. This is the current sense resistor that creates the main power, and is different from these other current resistors where we are having our 19. So here we're having 19. Remember our current sense resistor, we're having 19. Then you're having two input MOSFETs. These two input MOSFETs. You're having the two high side and two low side MOSFETs, creating the main power rail. We're having our BQ chip here, or the intercell chip, or the charging IC, and in coordination, this one controls all these MOSFETs, all of these, until here. So here, if we don't have these 12 volts, then you definitely know where the problem is, right? So that ideally is what I was. So let's just go back to where we were. We were checking out these. I was teaching you how to check generally before you go to the input MOSFET. And what happens is you check the coils first. For any short, you check the resistance of the coils, and that you change your multimeter into resistance mode, and plug your charger. Then we go coil by coil. This one, OL, open. That's okay. That coil is okay. Is that coil okay? We'll discuss about that. Is that coil okay? Again, we'll discuss about that. Same to that coil and same to that coil. There's a reason why they are beeping. That coil is okay, and that coil is beeping with 4 ohms. And this other coil, that coil is okay. You realize that the coils near the CPU are having very low resistance. That is simply because the CPU has very low resistance, has a low resistance to ground. Therefore, every other thing connected to the CPU usually has that type of resistance. So you'll confuse that to be a short, but it's not. Don't confuse that to be a short. And that is how it is. Fine. So all the coils, in my opinion, on this motherboard, all the coils are okay. All these coils are okay. And so what do you do next? You check the voltages of the coils. So switch and check the voltages. Switch to voltage. Checking voltage, you must plug it in. You know what you're looking for. We are looking for 3.3, we are looking for 5 volts, we're looking for 1.8, and so on and so forth, right? Now, we're looking for 1.2 here, which is missing. we're looking for 5 volts, which is present. We're looking for 3.3, which is present. And the primary voltages, our main power is present. The CPU voltages are absent. And that's it. And 1.2 is also present. 1.2 is also present. It just came on. So once you checked and saw that every other thing is okay, and in this case, you go for things like BIOS programming, that will eliminate the issues altogether. The secondary voltages, like the CPU voltages in this 6th generation laptops, they will come on once the BIOS has assured the motherboard is very okay and everything is okay. So if the BIOS itself has an issue, the CPU voltages might not come on. That's okay? Yes. The CPU voltages might not come on because the BIOS is not okay. That is just what we call the power sequence. Power sequence. There are a series of what should come on first, then the others should follow. But from here, maybe you should try BIOS programming, and probably you also do a thorough inspection on the motherboard, which we never did. That should be the first step. Is that okay? So at this point in time, you quite know that you have really understood the power input section very well, what to check, where the culprits usually are, and what to go for to what particular time. And that is going to be the end of our lesson. I've done about 1 hour 20 minutes of video. Thank you very much, and I think we should meet in the next video. Okay, today's class will not be there. That is why I made this long video covering all the questions you did before and our class today. So you have a good day, right? Okay. I'm ending the video.